conservative. Right? The two possible outcomes between and those case. So question A, using the minimax approach, so what is the best alternative for the attorneys? Question B, so the attorney believes there is a probability of 0.3 that he can win the case. So what is the best alternative for the attorneys? And question C, it is about a fee that if you want to consult with the expert, you're gonna pay for $2,000, and the expert is the one that familiar with this type of case and can provide another opinion on whether the case really want. So previous experience with using the expert can be summarized by the following table. So we have the result from expert to be predict win and lose the case, and actually about the outcome of these two. They want us to calculate the y probability, and so for the decision tree analysis to find the best decision for the attorney. And question D asks us about how much is the expert advisor to the attorney. So firstly, we need to do the minimax to get it right. So then I clarify just a bit. Okay, so let's start with this. So first is about question is about the minimax to get. Okay. So we're gonna have the table. Right, so let me write this. We have approach. Let's say that we have aggressive and conservative. So we have two possible outcomes. In the case, this case, we have 40,000 minus 10,000, 20,000 minus 6,000. So, sorry, I'm gonna leave this some space to calculate. Okay, when in the case of win for the outcome, the highest payoff is 40,000. So then we calculate using 40,000 minus 40,000. So the opportunity cost is opportunity loss is 0. But for the case of conservative, we're using 40,000 minus 20,000. So we're gonna have the opportunity loss is 20,000. The case of those case, we're gonna have the highest payoff is minus 6,000. So then we minus 10,000. We're gonna have 4,000 for the profit loss. For this case, we're gonna have 6,000 minus 6,000. So we're gonna have 0. Okay. And the next one, we're gonna calculate the maximum we get. So in this case, we're gonna have 4,000. And this one, 20,000. based on the maximum we get, we're gonna select the alternative that provide the lowest, right? Maximum we get. So in this case, is accuracy. And for question B, since we don't know about the probability, so it's become to the decision making under risk. So we need to calculate the expected value to make the decision. Right? In this case, let's say that we're going to calculate the EMV. So I'll calculate the EMV of the aggressive approach. So we're going to have 0.3. This is the probability of winning the case, multiplied with the payoff of in the case of using aggressive approach. We can multiply with 40,000. Okay. And plus another case is 0.7. This is the lowest case. We multiply with minus 10,000. Okay. So we're going to have 5,000. For the case of EMV of the conservative approach, we have 0.3 multiplied with 20,000 plus 0.7 multiplied with minus 6,000. So you're going to have 1,800. And again, based on the EMV approach for decision making under risk, we will select the alternative that provide the highest EMV. Right? So in this case is still aggressive. How about question C? Again, this time we need to cover the dy probability. So now I'm going to use a formula, okay? Not build up the table. Okay. So firstly, I need to find the property of predict win. The property of predict win in this case is going to be the property of predict win given in the case, multiplied with property of win in the case, plus the property of predict win given lose the case, multiplied with property of lose the case. So we're going to have 0.85 multiplied with 0.3 plus 0.05 multiplied with 0.7. So that's 0.5 multiplied with 0.3. 0.05 multiplied with 0.7. We have 0.29. So it means the property of predict lose the case equal to 1 and have 0.29. Then we have 0.71. So now for the dy probability, what do we want to find? It's about property of win, given predict win. So you want me to write down more detail or just the number?
Detail.
Detail? Okay. So we're going to have predict win given the win. We can have 0.85 multiplied by 0.3 divided by multiplied by 43 divided by 129. And point is 79. Therefore, the property of those cares given to the green will be 1 minus point is 79. Have 0.121. So we have this one and this one. About property of in the case given the those so we're gonna have 0.15 and 43 divided by 0.71. Therefore, 63. Therefore, the property of those predictable case 1 minus 0.063. We have 0.937. Done for the rewards, right? Then we're gonna do the addition tree diagram. The addition tree diagram. So we start with main addition that the consult with expert. Consult expert. So not consult. Not consult expert. You have two approaches, passive and conservative. Again, you have two possible outcomes. Right? Win and lose the case. Property is tried on for this case is 0.3 and 0.7. Come from the question B. Property of win is 30%. And to pay off, using the value from the table, this one is 40,000, this one is 10,000, this one is 20,000, and another 6,000. For the consult with the expert, we have two possible outcomes, right? Predict win and predict lose. You just calculate predict win is 0.29, predict lose in case is 0.71. Then we still need to make a second decision, especially for conservative approach. And win and lose the case. And for the rewired probability, in the case of Philippines, we have 0.879, 0.121. For Philippines, applicable here, 0.463. And for the payoff, remember that we have a fee for 2,000. So we need to deduct, right, the payoff in the normal case with 2,000. So then this one we're gonna have 38,000 and minus 12,000. 18,000 and another 8,000. 38,000 and 12,000. 18,000 and then 8,000. And then we calculate, right, the EMV for each outcome node. So this is, for example, the first outcome node we're using 0.879 multiplied with 38,000 plus 0.121 multiplied with minus 12,000. Here we have 31950. And another one. So we have 5,000, right? We have 18. So in this case, we're gonna select the alternative, that's why the highest EMV. So we cut off this one, this one, this one. So we have 5,000 here. And we calculate for the very first outcome node. So we have 4748%. So it's less than this one, so we can hold this. So the result is that should not consult with the expert. And the attorney should approach the accuracy strategy. You can expect to get the benefit 5,000. For question D, say that, okay, how much is the expert and y was to the athlete? So actually it's about, the value of information from the expert, right? So the value of information from the expert, actually this is called the sample information, right? So they ask us about expected value of sample information or UVSI. So that in this case, UVSI, so it's gonna equal to the ELV of the best decision, the case that we have information. So this case, best decision that we have information, ELV is this one. But if you look at the formula, it said that it's assuming no cost because when we calculate in the decision tree diagram, the case that we consult with the expert, we deduct the cost 2,000. So then we need to add it back. And use it for minus EMV in the case that we have no information. So case of no information is 5,000. Okay. So this case is going to be 48.48 add back 2,000 minus 5,000. So we're going to have 1748.48. This is the value of UVSI, or the answer for question B. So, one more. So, practice more. You can see that actually, if we're using the formula for rewrite this maybe faster. Okay, just one more problem, and we go home. We have the example of Mary. Mary is considering opening a new grocery store in town. She is evaluating 3 sites, including about downtown, the mall, and all the busy traffic circle. Mary calculated the value of successful stores at this location as follows. At the downtown, when successful downtown, we get $250,000. The mall $300,000 and the circle $400,000. Mary calculated the losses if unsuccessful to be $100,000 at either downtown or the mall, and $200,000 at the circle. Mary also figures her chance of success to be 60% for each location. Note that the alternative of doing nothing. Okay? So in the real world, we should include the alternative doing nothing always. Because sometimes we try to select that alternative, those alternative, but maybe stay doing nothing, maybe the best one. Okay, don't forget this one. So we have 3 questions or 4 questions again. Question A is maximum criterion, and question B is draw a decision tree and find the alternative. Question C, develop the decision tree and calculate the divide probability. And again, question D is about UVSI. Okay, so let's start. So in this case, I prefer to do a table for the first one to show you. So for alternative, we have the mall, right? Also downtown first. Downtown, the mall, and the circle.
Spring City. Yeah.
True possible.
But it's the one that
Right, success and unsuccess. So
not central Chiba.
we have success and unsuccess. So just we have successful. This one is 250. And then one success, we lost. And then so maximum, we try to find the minimum. So this is the minimum. And for maximum, we select the highest minimum.
Bring white.
So that's why we select these two. So for question A, the answer is downtown or the mall. Right, because maximum we try to find the maximum or the minimum, they all.
Maximum of the minimum.
For question B, draw a little tree and select the best alternative. So very simple, right?
Yeah.
They do have three alternatives. Downtown, the mall, the circle. And we have just two possible outcomes. So success and unsuccess. Right, and using S for successful, US for unsuccessful, okay? We know the probability is right because the program tells that the chance of success to be 60%. So unsuccess to be 40%. How about the payoff? Just using from the US table, right? So we have 250. This one minus 100. 100. Minus 100. 100. Minus 100. So then in this case, we have the EMV to be 110,000. This one we have 140,000. So we select the one that one the highest EMV. So we cut off downtown and the mall. So we select the circle. And we can expect that they are equal to 160,000. Right? 160,000. question C. So they have like a option to doing like a marketing research like that. It costs 30,000, right? The result of the research or the study show about the positive and negative, right? So positive survey using P and negative survey using N. So and then they tell us about the property of conditional probabilities, right? So they want us to calculate the UI probability. Okay. For success, I'm going to use S. Not success, but success, I use S. Okay. So in this case, what we have here, we have the property of positive result given success. We have 0.7. So probably of negative given success is 0.3. Probably of positive given unsuccess is 0.2. So probably of negative given unsuccess will be 0.8. This is all that we have. This is all that we have. So then I calculate the property of positive result of the survey. I will not provide more detail, okay? I'm going to show you that why it's faster. Okay, so in this case, it's going to be 0.7, okay? Okay, one thing that we know, okay, from the problem, we know that the property of success is 0.6, remember? The property of success is 0.4. So this here is going to be 0.6 plus property of 0.2. That is how we 0.4. 0.4 equal 0.4. Have 0.5. Therefore, the property of negative result of the survey is 0.5. 0.5. So how about we write probability? We try to find the property of success given positive. Add 0.7, 0.6, 0.5, 4. Therefore, property of success given positive is 1.5, 4. Another one is property of success given negative. Right? We have 0.2, and I will 0.6. And we're done. This is all I'm doing just is this is the information from the problem. You can see that if you're using the formula, it's very fast. No need to develop two tables. Okay, so we just and you can do something like this, but you need to make sure that your is correct. Okay, marking the score. Okay, so we have device, 4 device, and then we develop the decision tree. So then we develop the decision tree. So we're gonna have, this is the survey, more survey. You have the downtown, the mall, the circle. Positive and negative. So the case of this, we have we will have is 30,000. So let me calculate the EV. So then we select. This. We calculate for the first outcome. Then we still not consult, not doing the survey. Right? We not doing the survey and we select the circle. And this for question D. Remember, in this case, we use the base of the base of EMV for the case that we have information. We have 14400. As we know, what we add back 30,000 minus the case of no information or 160. So we have 14,000. This is question D. Okay. How do you close the case study? Right. Have two cases for the last one. But next week we can have guest speaker, right? So. And we're gonna see each other again. Maybe. Let's see. Oh, we're gonna have no. Making up class. So the next class that we have is this coming Tuesday, right? So the due date for the case is coming Tuesday. So we have weekend to do. Case is not difficult. The last one. Okay, this coming Tuesday we will study the last one. It's going to be utility, game theory, and Markov the same. Just introduction for each of them, right? Basics one. And for next Thursday is going to be guest. Okay, and for December 6th, we're gonna have the project presentation. Okay, so because I'm gonna be here for 2 weeks. Thank you. So that's it for today.